Welcome to solverfy.
For part A, we were asked to draw a ray diagram, and then from that ray diagram, figure out the distance to the object. So our ray diagram here shows the object in blue and the image inverted in blue on the other side of the lens. And the red arrows represent the rays, okay? So if the location of the image is 391 millimeters behind a 215 millimeter focal length converging lens, that means the object has to be farther than 391 millimeters away from the lens. So just from this, it's approximately 500 millimeters. So we'll write 500 millimeters, and that's just from assumptions based upon the ray diagram and how these rays have to work with this type of lens. So then for part B, we're going to go ahead and do the calculation. So we have the equation 1 over the distance to the object plus 1 over the distance to the image is equal to 1 over the focal length. Therefore, the distance to the object is equal to the focal length times the distance to the image divided by the distance to the image, d sub I, minus the focal length. So we can go ahead and plug in the values for the focal length and d sub I. So we have 215 millimeters multiplied by 391 millimeters. And since both of these have units of millimeters, millimeters times millimeters is millimeters squared. So we'll just pull that out front. Divided by distance to the image. So we have 391 millimeters minus 215 millimeters. Both are units millimeters, so I'm just going to pull the millimeters outside of this subtraction. So the millimeters squared and the millimeters are going to cancel to just give you units of millimeters. Carrying out this operation, we find that this is equal to 478 millimeters. So our assumption from the ray diagram of 500 millimeters was actually fairly close. We can go ahead and box that in as our solution for part B.